Let's look at a different system of equations. This one is going to require us to do a little bit of reorganizing in order to graph it on our graphing calculator. Notice that our equations in our system this time are in standard form, not slope-intercept form. We need to rewrite these equations so that they are in y equals mx plus b form. Let's start with the green equation, the first one. I've got 3x minus y equals 36. To get started, let's subtract 3x from both sides of the equation. Now I have negative y equals negative 3x plus 36. Our last step will be to divide all terms in the equation by negative 1. In slope-intercept form, I have y equals 3x minus 36. Let's do the same for the second equation in blue. I've got 2x minus y equals 22. Our first step will be to subtract 2x from both sides of the equation. Now I have negative y equals negative 2x plus 22. Last step, we'll divide all terms in the equation by negative 1. And in slope-intercept form, we have y equals 2x minus 22. These equations in slope-intercept form are what we will need to graph in our graphing calculator. Go to the y equals screen and let's enter y equals 3x minus 36 for equation 1. Use the down arrow on your cursor and we'll enter 2x minus 22 for equation number 2. Go ahead and hit graph, and we see that our equations are not in the standard window. We'll need to zoom or adjust our window settings so that we can see that point of intersection. Hit zoom on your calculator and select option 3, zoom out. Hit enter, and this will zoom your window out. Now, if you hit the trace button on your calculator, it will tie your cursor to one of the equations. Use the cursor to move up towards that point of intersection. Now let's hit zoom again. This time select option number 2, zoom in, and hit enter. The calculator will use your cursor position to zoom in on that particular location. Notice that our cursor was near the point of intersection, so our calculator zoomed in at that location. We can see approximately our solution to our system, but we'll need to use a different method to find the exact solution. Let's use the table of values. We're expecting the solution to be around the point x equals 14. If we hit second graph, we'll move the cursor down towards x equals 14. Turns out that was the exact solution. When x equals 14, the y value of the first equation is 6, and the y value of the second equation is also 6. That means the solution to this system of equations is x equals 14, y equals 6.